Good morning, and welcome to the Museum of the San Ramon Valley's virtual speaker series. I am Dan Dunn, the director of the museum. Last month, David Gotts, historian and archivist, told us of the rich maritime history of the towns of Tiburon and Belvedere. Today, another town. This month, Deep Oakland. Author and geologist Andrew Alden excavates the ancient story of Oakland's geological underpinnings and reveals how its silt, soil, rock, and that famous fault line are intimately involved with human history and the future. Andrew knows his geology and clearly loves the city of Oakland. He has authored Deep Oakland and a number of articles on earth sciences. As you will see from the book and from Andrew's talk, he's tramped around a lot, and he may even get you on a little bit more friendly terms with the Hayward Fault. Please use the chat window at the bottom of the screen for any questions that you have. Feel free to send in questions at any time during the presentation, and we'll address them at the end. And now it's my great pleasure to welcome in Andrew Alden. Hello, Andrew.
Morning, Dan. Nice to be here. Shall we begin?
Take it away.
All right. Let's screen. Start the slideshow. This I wrote the book Deep Oakland because I've lived here for 30 odd years, since just before the 1989 Loma Prieta earthquake. And I think Oakland makes a good subject for an entire book on its geology because, for one thing, it's a major Bay Area city. It's the third largest city in the Bay Area. It is a lot like every other California city in that it underwent 3 waves of human inhabitants, from the natives to the Spanish to the Americans. It is prone to earthquakes. It has mushroomed in population as well as every other city in California. And it's a gathering place of many cultures. It also has an unusually wide range of California geology. It includes coastal processes, tectonic processes, and an exceptionally wide range of rocks and landforms. And I've also found that in my decades of living here that Oakland's human history and its geological history intertwined in ways that I think deserve wider attention. So those are the factors behind writing this book. A bit about myself. I have spent a career in a sort of geology adjacent field as a scientific editor, and that's what this background is. This is a sample of the work that occupied me for the last almost 50 years. I've just retired, so I don't do that anymore. But I've also, I started out after college with the U.S. Geological Survey. And in that capacity, I was a scientific roustabout. I got to go along on 4 different research cruises in Alaska, the waters of Alaska, and I also spent a 2-week period on land doing a bit of field research. And then I served 10 years at the survey and then went freelance for a long time. And to do that, I assigned to myself the task of visiting all parts of California and writing about them as I went. So that's kind of my background. What I bring to this book is a thorough grounding in science and a long experience of writing for a general audience. So when we look at Oakland today, this is looking down at Google Earth. It it's hard to see a lot there. You see, the urban pattern, you see the hills, you see the middle ground, you see the coast, you see all this infrastructure along the shore and highways and so on. But I'm going to take you deeper inside, starting with this geologic map, which has been my guide to exploring this town since the year 2000 when it was released by the US Geological Survey. You can download this yourself. It actually covers a much wider area of the East Bay. It's just look up MF 2342 and that's what we'll be looking at. We'll see it a lot of times through this talk. When you look at it, you see that the high hills and the flats look quite different. The high hills are in bold colors, lots of different little fields covered with symbols. And the flats look pretty simple. And we'll be exploring them in turn. But what defines them, what defines the line between them is this thing, which is always on our minds in Oakland or anywhere in the Bay Area, because the Hayward Fault is a major earthquake source. It's also just a major part of the Bay Area's structure and California in general and North America and the Pacific in general. So this is the largest, widest setting of where Oakland sits, in the middle of this long zone of transcurrent faulting in which the west side is moving north and the east side is staying where it is actually, but the relative motion is southward. So, and here's what the fault looks like on the ground. It not only does it rupture in large earthquakes when the ground moves a meter or two, as much as 2 meters during large earthquakes, it also creeps a little bit in between large earthquakes. It moves a few millimeters a year. And this is what it looks like on the ground at Lake Temescal. And various places in Oakland, like this spot on 39th Avenue, where I visit regularly and photograph this offset curb conveniently marked by this saw cut. And that's also measured by a team of scientists every year or so. And in places like this, where you can see the effect over many years on infrastructure, like human infrastructure, like curbs. So that's the fault. I'm going to put that aside for now. I'm not going to talk about the fault much longer and go back to the geology, the landforms and the rocks. Oakland also has 2 special features between on the west side of the Hayward Fault. And I'll be talking about them in more detail. One is this block of bedrock that the city of Piedmont sits on, and this apron of ancient gravel hills that surround it that I have called the Fan. I call it the Fan in the book. I devote chapter 6 to it. I call it the Fan because it looks like one of those Japanese folding paper fans have been through a lot. And it has. The Fan has been through a lot, and that's roughly a million years of existence. This is what the Piedmont block looks like. This is a shot from the north end of Oakland, and you'll see from upper left is a notch in the hills running across down to the middle of the right. That is the mark of the Hayward Fault. And the Piedmont block sits on the other side of it, which is kind of unusual for this part of the East Bay. And it consists mostly of sandstone. I call it Franciscan, and that's just a name that geologists have given to this set of rocks, which extends up and down the Coast Range and was very mysterious for many years. What's important about those rocks is you'll see how close they stick out toward the shoreline, toward the city of Oakland, especially where, excuse me, where the city originated down by the harbor. And so in Oakland's early history, these, it was important to find sources of good crushed stone. And so there it was, right handy. And so each of these little Q marks, it indicates where a quarry used to be. And none of them are active today. But the three large ones here at the edge, the lower edge of the Piedmont Block, were very important in Oakland's growth and construction. The first one was in the middle. And then the two on the other side, either side of it, were the major sources of crushed stone for 40, 50 years until Oakland's development kind of overwhelmed them and put them out of business. And then, you know, that's in the lower part, the light blue part of the Piedmont Block. And in looking at the upper part, the dark blue block is a type of rock called melange. It's a mixture of kind of shaly sandstone matrix with these chunks of other alien rocks in them, like you'll see up on the hillside beyond the gravestones in Mountain View Cemetery. And of course, if you are familiar with the cemetery, they'll see large boulders and outcrops just scattered throughout the grounds. And that's part of what melange is. And that's why I featured the cemetery in chapter 4, a whole chapter devoted to this interesting area where the original landscape is still visible. And then we move to the fan, and you can't really see the fan very well today. You just kind of find yourself in the middle of it. But this old photograph, this old stereograph from 1876, shows the hills before they were developed. And you can see they form a kind of plateau, what I'll just call a dissected plateau. These little streams have cut into it, making picturesque valleys throughout the fan, which incidentally made it such an attractive residential neighborhood. This is what it looks like today across Lake Merritt. This is Haddon Hill. And, you know, you can sort of see the outline, but you don't really see the ground anymore. And that's been my great task in seeing through the human overlay to the geologic underpinnings of Oakland. But you can see why the hills were all, the fan of the hills were covered with homes at an early date, 100 years ago. This is when this happened. But I'm going to go back a million years and explain why the fan and this block of Franciscan bedrock is here. What I'm doing is taking you back a million years of motion along the fault. We know the fault moves about 10 millimeters a year on long-term average between earthquakes and creep. So you can go back a million years, and when you do that, it puts this block opposite this purple block on the right side at the opposite end of Oakland, just in San Leandro, right where San Leandro Creek cuts through the hills. And so my theory, which I expound in chapter 6, is that at this time, the two blocks of rock, the purple block and the blue block, were shoved together along the fault. And when two immovable objects are pushed together by an irresistible force, the only thing they can do is both get pushed upward out of the ground. And so I think that accounts for the rise of the San Leandro Hills. It accounts for the rise of the Piedmont Block. And incidentally, it accounts for this canyon that was cut across the Franciscan complex near its right side. That's Diamond Canyon. And so that's kind of These are kind of the key pieces of evidence behind my theory. That's what happened. The tectonics accounts for that particular feature. And I'm going to zoom in a little closer and look at the downtown in detail. Oakland's downtown area, central Oakland, is really unusual in the whole East Bay. It's got all these odd features, extra features that don't appear anywhere else. One, as I explained, was the bedrock block and the fan around it. But I'm going to talk about these two large features. One is, it's labeled QDS, and that stands for Quaternary Dune Sand. Quaternary is simply a term for the last 2.5 million years, which encompasses all the ice ages that we've been having recently in Earth history. So that is Ice Age dune sand. And then there's this dark blue feature right around Lake Merritt, which is not labeled. It's labeled elsewhere in this map, but it stands for marine terraces. So I'm going to look at both of those. This is what the original ground looked like before most of Oakland sat here. This is a 1857 map, first good map of Oakland. And you can see two landings. You see Oakland in the center, and then way over on the far right, you see a little town called Brooklyn. And both of them took advantage of natural landings on this channel leading from the bay and up into Lake Merritt. And both of them took advantage of those two geological features I mentioned, Oakland on the Merritt Sand and Brooklyn on the Marine Terrace. So the Merritt Sand is hard to see because, of course, it's covered by downtown. But if you're down at the mouth of Lake Merritt, you can see it very clearly. All these major Oakland buildings are built upon it, and the edge of it leads down to the lake. And this is what is underneath it. It's a fine sand. It's got some clay in it, which makes it very firm, makes it good building foundation. It's also easy to drill water wells through. And so it was a natural place to found the city of Oakland. And here's the Marine Terrace as an example. This is the part of Lakeside Park. It's a beautiful flat ground, sort of gently rolling, kind of custom made for a really nice city park. And then here's the other end of it down in East Oakland. And that view particularly shows just how flat it is. That was laid down at a time during the ice ages when it was especially warm, just like today, only even more so. It was so warm that the sea was a good 10, 20 meters higher than today. And so all the streams in the hills at the time carried all their sand and gravel down to that higher sea level and laid it down in this stuff. This is what's underneath Lakeside Park. And then when the ice age kicked in, the last cycle the ice age kicked in, the sea withdrew, and this terrace was left behind in many places. In many places it's been erased. But this is what it looks like. It's got gravelly, clayey gravel, and on top of it a layer of clay, which collected on the, in the marshland that was the coastline at the time. Both these pictures are from Lakeside Park. I hang out there, and whenever they open up the ground, I try to take pictures. So those are the major features of Oakland's landscape. And now I'll talk about what that meant for the people who have three waves of people who have lived in Oakland. Again, this is what they are. This is the habitat that geology represents. We've got alluvium, we've got ancient alluvium, we've got sand dunes. All that pink stuff is stuff that the Americans have built since 1850, for the last 170 years, which is a pretty amazing transformation of the original landscape. This is what the Ohlonies, who lived here first, saw here. They maintained it most of the flats as meadow. They would set fire to it regularly to keep the trees down, except down in the sand dune flats where they maintained large groves of coastal live oak. It was very handy for firewood. They collected acorns there, although they weren't the preferred acorns. They were good in a pinch. And of course, they used the wetlands and the estuary to hunt game and collect various plant materials. They left the hills alone. They burned the hills too. Redwoods are immune to burning, but they burn them anyway, just to keep the undergrowth clear. And that's how they maintained this landscape as a setting that supported their lifestyle for thousands of years, ever since they came here, sometime after the peak of the last ice age. They watched the sea rise and they adapted to it. And they lived here at the time the Spanish came. Another odd feature, a unique feature, which I'll get back to, was a deposit of ochre up in the hills. Ochre is a set of mineral pigments. It's an earthy material, and it's kind of unique in the Bay Area. The Ohlonies cornered the market on ochre. This was their main trading good that they traded with other tribes around the Bay Area for things like obsidian arrowheads, like salt from the South Bay, or decorative beads made from abalone shells from the Pacific coast. And the Spanish came in, the missionaries cleared the tribes at gunpoint. They used soldiers to round them all up and took them off the land. And they set cattle loose on the nice coastal plain. And then a generation later, as the mission system wound down and the Mexican Revolution happened, they awarded the lands, the Spanish crown awarded the lands to various important people as rewards for their work. And that was how the Rancho era happened, it was a short era, actually, just no more than 50 years. And in fact, the first rancho was awarded in the East Bay, including the land that covers Oakland today, in 1820. And Luis Maria Peralta divided that land between his 4 sons. And the two sons who were in charge of Oakland were Vicente here in the north. His ranch was in North Oakland. And Antonio Peralta, whose ranch was in East Oakland. And between them, they divided this land and used it mostly for cattle range. They used the wood, the groves for firewood. They didn't care about the acorns anymore. And they each had shipping channels along the shoreline for their purposes. They traded cattle hides and tallow for various manufactured goods in their particular rancho lifestyle. And the Americans came in, they founded the city of Oakland. They founded the city of Alameda and Berkeley and San Leandro, and proceeded to develop downtown. They built up the shoreline and built industries there where there was plenty of water available. They built up the land and built seaports there. And in this century, they built an airport there. They built railroad lines there. And in the middle ground, the flats and the hills and the foothills was devoted to residences. They paved it all over with residential neighborhoods, which are classics of their kind. They also eliminated the redwoods. In fact, the redwoods before anything else. The redwood rush began in the 1840s. And they used the port, not of Oakland, but of Brooklyn, for most of their shipping. So, aside from a couple of historical accidents, Brooklyn might have been the major city of the East Bay. And we might be calling Brooklyn instead of Oakland, which is an interesting bit of alternate history I like to think about sometimes. And then, back to that ochre deposit. The Americans discovered it around the turn of the last century and realized that underneath all that ochre was a huge deposit of pyrite. And that supported a short-lived industry based on mining pyrite, roasting it into iron oxides and sulfur oxides, and then turning the sulfur oxide gas into sulfuric acid. That was the payoff. It supported the chemical industry for a period of several decades until new sources were found. Pyrite is no longer mined for sulfur. It's mined for precious metals and copper, that sort of thing. But what the Oakland pyrite mines left behind was acid drainage, because when you open up the ground, sulfur digesting bacteria move in and turn all that pyrite into rust, iron oxides, just like they were doing naturally for all those tens of thousands of years. And then their waste product is sulfuric acid, and that's what accounts for these rusty colored waters and acid creeks. We're still living with a legacy that time 100 years later. So that's the flats and the hills. We've got a bunch of rocks, and I'm going to go through them rather quickly because they're very diverse. They're a huge set of stories. And we'll start with the Franciscan. They've got all these kinds of rocks. And as you get to know them, they're old friends. And then we've got the older rocks in the hills, which are all representatives of a suite of the Earth's crust, pieces of the Earth's crust, seafloor, carried up and deposited on land. That's called ophiolite. And there's a whole distinctive set of rocks connected with the ophiolite from Gabbro and volcanics. These are the volcanics that gave rise to the ochre deposit. And then up in the hills, we have this huge serpentine belt and the rocks related to it, blue schist and peridotite. And then the middle-aged rocks are the same rocks we find out in the inner Coast Range and the Sierra foothills, shale and siltstone, these sedimentary rocks. And in Oakland, I get to count a few rock types that aren't really part of the Great Valley. They're carried down from the Sierra Nevada. And these represent the rocks found in the Sierra Nevada, the granite and quartzite, that kind of thing. And so all of these three sets of rocks represent the pieces of your classic textbook subduction zone. Subduction zone is well, plate tectonics works. You have the seafloor spreading, it moves down underneath the continent, and along the way it produces all these different kinds of rocks. The material on the seafloor boils up, it melts the rocks above it and yields this volcanic arc. That's the Sierra Nevada. And the trench and the foreland in between have their own specific sets of rocks, and they all fit in that in this setting. And what has happened, it's no longer a subduction zone in Central California. It still is in the Pacific Northwest, and it still is way down in central Mexico. The growth of this subduction zone between the two triple junctions moving north and south has dismantled that old subduction zone and broken it into pieces and brought them all up into the surface for geologists to study. And so geologists for the last 60 years have been piecing together how subduction zones work from the pieces left in California. And so Oakland is really cool in containing not only all those pieces of the subduction zone, but pieces of the breakup of that subduction zone. And so that's a whole separate story, each of which, every one of which could be a separate talk. I'm just saying that they're all here in Oakland, which is kind of amazing. That's why Oakland is so special and why I could write a whole book about it. So with that, let's open the field up to questions. I'm sure there have been a bunch of them coming in through the chat and maybe from you guys too.
You're right, Andrew. So I've got a few that we can cover. You and I are both East Coast people, and I was surprised in going.
Excuse me. I got my degree in the East, and I was raised in the East, but California is the first place I remember. I'm a Californian.
All right,
all the way down.
Fair enough, because that's where this question's going. So. I was surprised at the diversity of the underpinnings of Oakland. What is it that makes Oakland special compared to the other cities in the Bay Area?
Yeah, well, to me, as I studied Oakland, it came as a pleasant surprise to learn about the Ice Age features in Oakland, that Ice Age sand dunes, which I didn't quite explain that, but when the Ice Age was at its height, the sea was 400 feet lower than today, and so the winds blew sand off that huge, widely exposed shoreline all the way over San Francisco and across the bay and all the way up into Oakland. So that's kind of one Ice Age thing. And then the marine terraces that I explained are from the warmest phases of the Ice Age. So anyway, yeah, seeing those in one city, because they're not obvious anywhere else in the East Bay, they're just little traces here and there. So I thought that was especially cool. And I could relate to it from, growing up in the East, in New England specifically, which is covered with glacial drift. It's covered with not rock quarries so much as sand and gravel quarries that dig into this stuff. And if you study the continental shelf in the East Coast in geology school, they tell you about all these canyons that were dug across the continental shelf during the ice ages. So it was cool to see all that here on the West Coast too. I thought, I haven't left the East Coast entirely behind. And it's all here in Oakland, in this particular city, and nowhere else.
Speaking of that particular city, and actually relating back to your book, as I was reading through it, I kept thinking, gee, there are places here, and you kind of lay them out for us that you can go see a lot of these features, and using your book as kind of a walk-around guide. If we had maybe an hour or two, what are some really good walking geological evidence trips that we might be able to take?
Yeah, I actually have a slide for that. And these are my recommendations from Lake Temescal in the north. That's where I had that picture of the cracks in the ground. There's an interpretive sign there, which so makes it really obvious to see fault creep. And if you study a bit about what the Hayward Fault does to the landscape, you can see that around you when you visit there, as well as seeing that the two sides of the fault have exposed different kinds of rocks because they've been carried together. So that's the cool thing about Lake Temescal. Lakeside Park is a good place to see the Ice Age features I mentioned. Diamond Park shows that canyon cut through the Piedmont Block. It's a classic water gap. It's another kind of East Coast feature. They teach you, if you go to geology school in the East, it's all about water gaps in the Appalachians. We have a splendid water gap here in Oakland. It's right there in Diamond Park. Middle Harbor Park is a great place to contemplate what we have done to the coast. More so in Oakland than anywhere else in the Bay Area, I would say. It's just, Oakland just pulled itself up by its bootstraps, building this world-class harbor, making itself a great city by its own efforts. And Serpentine Prairie is a great place to see the Serpentine Belt, which is very special. There are bodies of serpentine all up and down California, up and down the Coast Range, and we have our own piece of it here. It's special for the biology that grows on that special rock, and there's interpretive signage there to help educate you. And Nolan Park, that's kind of a hidden gem. It's completely undeveloped. This is up above the Oakland Zoo. And it's just an example of the same kind of ground we saw in Mountain View Cemetery, a melange terrain. And you can see it without any signs, without any gravestones. You can just wander around. It's all grassland. It's a neat place. So those are my recommendations. If you gotta, you want to make an afternoon outing to Oakland, visit one or two of those places.
Yeah, cool. How about the volcanic areas in Sibley?
Yeah.
Can you talk about those?
They, but by all means, you could go up there too. It's full of interpretive signage. You won't really see a volcano. You'll just see a bunch of volcanic rocks, because the same forces that pushed up the Oakland Hills over the last few million years have pushed everything up there sideways. So if you can see a volcano at all, you see it in cross section. But there is interpretive signage. There's all sorts of cool volcanic rocks up there too. I think that goes without saying that any of the Oakland Hills parks, the regional parks, Tilden, Redwood, Chabot, and Sibley, they're all great places to visit. I can recommend them all.
Okay. We have a question from someone who grew up along Diamond Creek, and you actually addressed this in the book too. How was Diamond Creek formed? Is that through a crack in the Piedmont Block and then water erosion from there?
Yeah, I kind of alluded to it earlier. I said that when you push the Piedmont Block, or if you kind of rewind it a million years, you find yourself right next to San Leandro Creek. And if you go up there at Lake Chabot Dam, it's a big canyon. It's impressive. It's hundreds of feet deep. And Diamond Canyon is just the same way. And so by my theory, which no one has convinced me to abandon, although in a couple of weeks I'm gonna deliver a talk to the Northern California Geological Society. These guys are my friends. They won't hold back. If I'm wrong, they'll tell me why. And they haven't told me yet, so I kind of think that I'm on good grounds here. I say that San Leandro Creek, which has a very large watershed, that's why we built reservoirs on it. That creek was vigorous enough and strong enough to dig a canyon, even while the Piedmont Block was rising across it. And that's why it's a water gap. But it got carried along north, and various streams in the hills that had passed along the way have flowed through it. Arroyo Viejo Creek what used to flow through it. Peralta Creek used to flow through it. Today, Shepherd Creek, and Palo Colorado, what is it? The one draining Joaquin Miller Park, they're running through it today. In a few 100,000 years, Temescal Creek is going to flow through it. But none of those creeks actually cut the canyon, just the San Leandro Creek. So, you know, Diamond Creek, Saucil Creek, excuse me, the part between the canyon and the bay, that's always been there. But the part above Diamond Canyon has changed over 1 million years. It's changed. It's swapped headwaters. I call it a Frankenstein Creek.
Yeah. So I also think that as in reading your book, you do a really good job, and actually you showed a couple slides which reflected it, of talking about the human impact and how the Ohlone changed the land, and how the Rancho period changed the land and into modern streets and airports. Is
And
that something that
mines and quarries too?
yeah. Is that something that you, as you were writing the book, was that important to you to talk about the impact that humans had made going back to the original inhabitants?
It was essential. And I did want to point out that the Ohlone didn't just live in a wilderness. It was a homeland that they shaped. You know, they managed it as intensively in their own way. As if all you have is fire and sharp sticks and stone tools, this is what you do. They managed it just as effectively and as pervasively as we are managing it today. And the larger point of talking about all these ways of human interaction with geology and geology interacting with humans is looking ahead. Looking ahead, we're going to have to change the way we live on the earth. You know, it's as simple as that. We're going to have to keep mining. We're going to have to keep finding water sources. We're going to have to keep finding fertile soil and growing things on it. And yet the way we're living now is threatening that. And namely the use of fossil fuels, which has transformed the world in just the last 2 human lifespans, to the extent that it threatens civilization itself. So, you know, it's a big problem. This is a worldwide setting. And I've always said that on a round Earth, every place is at the center. Oakland is the center. To me, Oakland is the navel of the world. Oakland is a world-class city. And that's, people can say, well, that's exaggerating. It's a major American city. It's a really cool place. And I want Oaklanders and East Bay people to be aware of that as we work the rest of our lives and our children's lives to try to bring about the next world.
And that's actually kind of the theme of the last few sentences in your book, is that idea of the need to look ahead and think about the impact that people have had. How about the San Ramon Valley? I'm sitting here in my office right now. I've got Mount Diablo out my window. I got a great view. How about the geology of this valley?
Well, while I was working on the talk, I did put one together. This is a composite of the geologic map of Alameda County on the bottom and the geologic map of Contra Costa County on the top. Just why you see this kind of seam across the middle of it, because the maps were made by different geologists at slightly different times. They decided to recognize slightly different geologic units. So that's kind of why it looks the weird the way it does. But I've labeled the towns on it, the major towns, and the kind of cool things to be found over there. I think Crow Canyon is cool. You drive through it and it goes through this set of hills that are just as the rocks at Sibley are all folded and uplifted and turned upward. So are the rocks in Crow Canyon, and it's all almost wild there. You can pull over and just stare at it. Take the little side roads and check it out. The Las Trampas Wilderness is a really neat place to go for the views. And of course, Mount Diablo itself, which you go there, you can get a geologic map of the whole park, which was just made a couple of years ago, which shows the incredible detail to be found there. In a way, Mount Diablo has just as much variety as Oakland does, as far as the rocks go. The Chasahara Hills are neat, just too. That they remind me of the Fan in Oakland, that they're young hills that are gently uplifted and then dissected by younger streams, and they're all grassland, the way the Fan used to be. Pleasanton Ridge has been recently opened with walking trails, and of course the rocks there are totally different. Those are the older rocks that I mentioned in Oakland with the darker green colors. They represent the Great Valley sequence. And Quarry Lakes, you go down there and you can actually see what's underneath the ground, all up and down the San Ramon Valley. It's all gravel that used to be worth money. And when they finished using them for quarries, they gave them to the county for parks. And so you go there and you look around the edges of these lakes, and it exposes these gravel beds that have poured down from the Diablo Range to the south over the last few hundreds of thousands of years, filling up the Livermore Valley with coarse alluvium. So those are some of my geologic highlights over there.
Thanks for putting that slide together for us. That was it's interesting to see all that and get your take on this.
I also want to point out that you've got your own earthquake fault, the Calaveras fault. The Calaveras goes all the way down from about Danville, all the way down past Gilroy. Now the northern segment of it, the segment that splits apart from the Hayward Fault, is not as hazardous as the rest of the Calaveras Fault. We're not really quite sure how hazardous that segment is. It seems to have caused an earthquake in 1891. We can't really tell because the records aren't very good. The fault trace itself is covered by large landslide deposits. We just don't have a good sense of it. But you do have a fault that seems to connect to all the other faults in the Deep East Bay. And so that's something you ought to be concerned about too, just like we're concerned about the Hayward Fault in Oakland.
Yeah, we do worry about both the Calaveras and the Concord Fault in this part of the East Bay. So yeah, that's true. And Andrew, I think that's it for questions for us. And what I've got to say is that I had a blast with this book, and I would recommend everybody grab a copy of this, get yourself a good map, and then go follow the paths that Andrew's laid out for us as you explore Oakland. Obviously, he clearly loves the city, and I think he does a wonderful job in sending us to the various places. Andrew, our last question. The photograph that you used right at the very end, which had the flowers, there was a wrought iron gate behind it. Where was that?
That's
That,
the gardens at Lake Merritt. That's a beautiful
okay.
iron gates they put in over the last couple of years. This is the side by the as you drive in. So yeah, check that out. It's full of rocks too. It's got a rock garden. It's got a bonsai garden with Japanese suiseki rocks. These are the artistic rocks that Japanese collect. And there's a California Suiseki Society that's got them. And anyway, I'm thinking of putting together a whole tour of just the rocks in the Lake Merritt Gardens.
Don't lose that photo. It's a great photo.
Thanks a lot.
Yeah, and thank you, Andrew. Thanks for taking time with us today. And thank you to everyone who viewed this morning. If you missed any of the earlier programs, you can find them by visiting the museum's website at museumsrv.org. Today's program with Andrew will appear early next week. As you know, if you've been doing this with us for a while, the monthly program series takes off July for vacation. So join us on Thursday, August 17th, when author John McCormick shows us how the Chinese laborers became the backbone of the Napa Valley. You may remember that this museum did an exhibit on the Chinese railroad workers and how they scattered through the area at the conclusion of the building of the Transcontinental. John McCormick will be talking about that with us. So yes, it's early in the day, but get yourself a nice glass of Napa wine, and that should fit the theme of the day. As a reminder, the museum's gala at our historic 1888 Taxahara Grammar School will be held on July the 15th. Go to the museum's website for information and tickets. If you like these programs and want them to continue, we ask that you make a donation by going to the museum's homepage, museumsrv.org, and clicking on the Donate Now button. The museum is also in need of volunteers. If you can give us some time, please contact us. I hope you enjoyed today's presentation. Thank you again, Andrew, for your time and your efforts with us.
It's been a pleasure.
Stay safe, all of you, and thank you for watching. Bye-bye.